Okay, this says consider the function f of x below over what in open intervals is function decreasing and concave up. Give your answer in interval notation. All right, so we have to do them. We're going to use the first and second derivative test, and we'll use it this way. So we have to take the first derivative of the function. And we'll go ahead and simplify. Okay, then we need to set this function equal to 0 to find the critical values. Now, what we're going to do is we're going to factor this function, try to figure out the critical values. And that's going to require us to use something that you would have learned in a previous course, which is the rational zeros test. Since this is a 1, and obviously this is a 36, we have to look for all the factors of 36. So 1, 2, 3, 4, 6, 9, 12, 18, and 36. And also the negative ones. So the positives and negatives. And fortunately, this is a 1, so we would have to divide by 1. And then use something like synthetic division to figure out which ones of these are actual zeros of the function. Okay, so I'm going to go ahead and take all the coefficients. And we're going to make a guess that -2 is, which is the same as -2/1, is going to be one of the zeros. So bring the 1 down. That's 22. So 18. It's minus 36, which is 0. So indeed, that is a 0. So then let's use this space over here. Actually, we'll do this because we're going to have to do the process one more time. So we have x plus 2, since this is a 0, and then we're left with 1x squared plus 11x plus 18 equals 0. And then this is a quadratic, so let's see if we can factor it. That's 18. 9 times 2 is 18. So x plus 2 and x plus 9. And so we're able to factor it this way. And then determine that x equals -2 and x equals -9 are critical values. Okay, so with that said, we're gonna do the rest of our work over here. And I think it'll be worth making some lines over here because we're gonna need to have some intervals. And I believe we're gonna end up with 4 intervals, perhaps 5. There's one more piece that we need, however. So let me go ahead and make some space by removing our work at the bottom. Because now we need to take the second derivative. So I'm just going to remove that corner. All right, so now we're going to take the second derivative. So that's going to be 3x squared plus 26x plus 40. And set this function equal to 0. And once we have some intervals, we'll be able to draw some conclusions. That's a 3 there. And I just need to figure out what the factors are. All right, so I paused for a second and had to do a little bit of trial and error. And it turns out that 20 and 2 are what makes this work, because 20 times 2 is 40, and then the outer is 6 and the inner is 20, so that gives me the 26. So then the next value that we need to get here is by setting this equal to 0. So x is minus 20 over 3. And then we get that x equal -2 showing up again. All right, so we should be able to come up with a few. Okay, so what I'm going to do now is take my values, my critical values, and create some intervals. So we're going to start from -infinity to -9. I'm going to put these in order. And then, so then we're going to go from -9. And then it turns out that -23 is the same as -6 2/3. So that it helps to know that that's the next one here. So we could leave it as -6 2/3. It'd be easier to work with. And then we'll do a -6 2/3. And then go all the way to -2. And then we'll go from -2 to infinity. So that takes care of all the critical values. Obviously, these came up twice. All right, so now I need a value inside each of those intervals. Let me just use a different, well, no, I think we can keep that. So this is going to be x equals 10 is -10 is easy to work with. X equal -7 might be easy to work with. And over here, I can use -3. Or we'll just use -3. -3, -5 would have been another good choice. And then over here, I can use 0. Okay, so now what we're going to do is first I've got to clean up my space here, right? So we'll need this for sure. So I'm going to move this up just a little bit. Because I'm going to input our critical values into my first derivative to determine whether the function is increasing or decreasing. And then I'm going to plug it into the second derivative to determine the concavity of my curve. And I don't think I need these anymore. So, and we are getting closer to the end here. A little patience and a little bit of luck that I don't make very many mistakes here. So we're going to go ahead and plug in a -10. And then we're going to plug in. So we're going to plug in all our critical values. And what I'll do is I'll pause the tape, pause the recording so that I can compute these. And really, I'm interested in the signs. So we've got 2 more. And we've got 1 more, which is the easier one. Not sure why I put a 0 there. And then, so I've got to do all those computations and determine the sign. And then I've got to do the same thing for the second derivative test. Determine the concavity. So we're going to plug in a -10. We're going to plug in a -7. I'm going to plug in a -3. And then we're going to plug in our easy one, which is a 0. Okay, and I'm going to go ahead and pause so that I can solve those and get the sign. Okay, so I think it's worth me showing you how I'm going to go ahead and compute these rather than doing them by hand. I'm going to go ahead and put them in the calculator, and then I'm going to go bars, y bars, enter, enter, and I'm going to start plugging in our values, which were -10. And I'm just going to follow the same process. So bars, y bars, enter, enter, and I'm going to plug in a -7. It's almost as easy to just go in here and just change the input. So the next input is a -3. And then the next input is a 0. So I'm going to write down on my other sheet, negative plus plus plus. Negative plus plus plus. This means that it's decreasing, increasing, increasing, and increasing. That means a function f is decreasing, increasing, increasing, and increasing on those intervals respectively. And then I used the second equation, y2. And I want this, that's for the second derivative, and I'm going to plug in the same values. So now I've got concave up, concave up, concave down, concave up. So up, up, down, up. And now I can look for intervals where it's decreasing and concave up. And that would be this interval right here. So quite a long problem, but that's how you find the answer there.